Hello, we will study about ensemble learning basics. The basic idea of ensemble learning is that we train several learners and each of them gets slightly different results on the data sets because we are training different learners, say L1 and L2. So L1 would learn certain things and L2 would learn some other things. That means the inherent concepts of the data would be captured differently by the different learners L1 and L2. And then we will put them together and the results would be combined in some manner, which we will study very shortly. And the idea is that the results of the combined learners would be better than any one of them on its own. Any one on its own would be giving you weaker results than the two combined together. But there are issues. What are the learners we would want to use? Then how do we ensure that these learners are learning different things? Otherwise, we would have duplication, which would not add to the learning. And then how to combine the results? We'll see very shortly. So there can be various approaches to address these issues. In fact, the different algorithms work differently and that is how they differ actually. So which learners to use? This would depend very much on the data. You could use nearest neighbors, you could use decision trees, and even other classifiers. And how to ensure they're learning different things? One thing we can do is train them on different sets of data or maybe different features on the data. So from the data set, we either combine some data and we make several subsets, or we would also make combinations on the features. And how to combine the results? We could do the averaging for regression, that is average of results, some kind of aggregation that is, and majority voting when we are having the classification task. So these are the approaches which we would be taking when we study about the different ensemble classifiers. So the data dependent decision of the learners to make them learn different things, we train them on different sets of data or features of data, and how to combine averaging or majority voting. Now some concepts: instance bagging, putting in bag. So instance bagging, we have data and we will randomly partition the data and give these different data sets to different classifiers. Okay, this is instance bagging, but then we would have to take a decision of will the partitions be separate or would include overlaps. So these would be the design issues when we build the classifiers, ensembles. Then feature bagging, combination of features, not all the features. When we are training different learners, we may bag the features. So when creating partitions of data, we take only subset of features, okay, some subset of features and not all of them. In fact, random forests, a very popular classifier, ensemble classifier, follows this approach. The ensemble method types, parallel ensemble methods and which are also known as the bagging methods, and sequential methods known as the boosting methods. So the bagging, the base learners are generated simultaneously. So this is parallel. So we would create data sets, give them to the learners, and they are being trained simultaneously, and then the results are combined by averaging or majority voting. So this is the parallel method. Sequential methods, also known as the boosting techniques, different learners learn sequentially. So we would have early learners which would fit to simple data points and then the errors are analyzed. And then the next ones would pay more stress on the misclassified samples and then try to classify them. This would result in boosting the overall performance, hence the name boosting. So in this video, we have just simply gone through the basics of ensemble learning. What is the why the reason behind it? We want to train learners with different concepts and for different learnings. For that, we would do instance bagging, we would do feature bagging, or we would take the sequential boosting method. So in the next videos, we would go into more details of bagging and boosting. Thank you for watching. Thanks.